me, I like to talk about me because I'm an artistic, and also because it gives you context to actually understand how I see things. So I am an engineer from France, so I basically, to make it very simple, I'm not very good in technical stuff, and I'm quite good at big picturing stuff. Well, that's half true because I've been doing a lot of technical things since I left school, but that's how where I come from. Other thing, after my school, I joined a team who was dedicated about open source. We were providing both support and expertise about open source technologies, which include free software. And during those 4 years in this team, I became a committer on PMD project, which is a Java tool, and also became a main contributor to Xradar. And finally, in like 2 years ago, I became involved into the Mercurial community by translating the HD book into French. At last, I'm still teaching at my old school, the school I graduated from, which is called ESME Sodoya, and I'm teaching build technologies on OOP programming. So I'm kind of in the middle of like industries, but also school. So yeah, that's it. Well, quickly, this is just the ad. I'm working for a company called Number 4 now, which is situated in Berlin. So if you want to do cool stuff in Berlin, you can apply. We are recruiting. That's done. Okay, first thing, this talk is called Scala Expressiveness, which is kind of weird. So let's just think about what expressiveness means. For other people, expressiveness is about writing small code. Like, yeah, I can write my code on this bottle of water. That's cool. That may be cool, but it's not really expressiveness. Expressiveness is how much your code conveys the idea behind it. So for instance, if you look at the first example, Python against Java, well, clearly Python is more concise, but also it brings you more expressiveness because like you just say I want a range going from 3 to -5 by a step of -2, which is kind of making sense. If you look at this thing here, well, you can figure out what it means, but it's going to take a while. Now, other comparison, Python against Perl. Well, Python against this way of doing this in Perl. I guess there is a better way to do that. Same thing again, if you look at Python, it's maybe somehow a bit longer than the one in Perl, but it's kind of making more sense. It's more easy to understand what's happening here than here. Also, because Python is a compiled type system, on this thing is actually, well, because Python is actually handling regex as like compiled thing, you can compile this expression and reuse your regex, which you can do with Perl, which also brings you more expressiveness. The idea is not to say that Python is better than Perl, Java, or whatever. The idea is also that depending on what you're doing, expressiveness of a language may change. So that was a little introduction about this. So what does it really bring us? I mean, why do we seek or not expressiveness in programming languages? Well, the first thing is high level of abstraction. We always seek for high level of abstraction, otherwise we will still be playing with, I don't know, assembler system. This, of course, brings us a more easy way to express ourselves because the more higher level we are, the less we have to take care about little things behind. So if you are writing web services, for instance, you don't want to worry about network connection, TCP/IP error, or this kind of stuff. You just want to write your web services and just hopefully create something that's working over the web. Also, we want to have expressiveness because basically we wrote less code. And the thing is that the less we wrote code, the less we expose ourselves to bugs. If we go back to the big sample of Java code we just saw, there is many ways to get something wrong here. We can put +1 instead of +2, we can change a sign. The Python way with this range function is more efficient and less prone to bug. And of course, the more your code conveys sense, the more your code is expressive, well, the less it's readable. And it's far more better to spend 3 hours writing 3 lines of code rather than spend like 1 hour writing like a huge bunch of code. It's going to be quite difficult to read after a while. So let's start with the first example. No, not yet. Yeah, no, first Scala. So a little bit about Scala. I don't know how much people here know about these languages. So basically it's running over the JVM. So it's like written in Java and run over Java. I guess there is port now. I mean, there is port like you can run Scala over, I think, Mono on some other languages, but whatever. Basically, this language is like providing you with OOP programming languages. You can have classes, you can have inheritance, polymorphism, methods, this kind of stuff. But it's also mixing functional programming, which means that you have Closure, you have, function as a first-class citizen, this kind of thing. Which makes Scala a very, very rich and complex syntax. Basically, I think Scala can even kick its ass to C++. And I mean, this is already very complex. Well, we'll see when we are going to see to the code that Scala has a very, very many keywords and stuff like that. But also, it's still strongly typed languages. It's not like Groovy, which is like not type. It's still strongly typed, and it's also helping you by using inference. Basically, it's trying to deduce the type of the current values or variable. So you don't have to do this thing that we also see in Java, like list, string, equal new array list string. No, you just write val equal new list, and it's going to be able to say, okay, you just want to create a new val, which is a list. And because you put string into the list, it's a list of string. So it's going to deduce basically the typing, which really help you because you can just leave out all this typing stuff and still have the benefit of typing, at least if you believe in typing. Well, some people don't, so whatever. Okay, first example. Well, this is kind of obvious. You have like these classical POJO classes of Java, so you got like all your private stuff, public method to get access to things, where getter setters, you got this equal method you need to write, you got this hashcode method you need to write, you got this public to string you need to write, because those are badly done by default in Java. And you got in Scala, this is what we call case class. Case class is basically going to do all of that for you, first time correctly. I guess expressiveness is kind of obvious. I mean, you just wrote 4 lines and you really know what you have. And again, you can see that it's still strongly typed. I mean, this returning a string, those are string. We are not having like a Groovy or a typeless language. Okay, next example. Pattern matching makes it safer. As you can see, well, this is like an example of how to handle branching in a code in Java. Well, given, to be truthful, this is a bad example. One can do better in Java. I hope you are seeing stuff because the red thing is not really, well, whatever. So basically you got this huge if statement where you are doing stuff like if my list is not empty, get this thing and equal to that thing and blah, 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 blah. Okay, so that's crappy, and basically you can either have a special case, a valid result, or a partial result. At the end, you just print a message. Here, you got this case statement, which is very powerful in Scala, because this case statement is allow you to actually match against type. So if you just pass to the case statement a valid list with the content you expect, like 1 and 2, it's going to go to no hop. If you pass a list with 2 and 4, it's going to go to valid result. And if you pass something else on a list, it's just going to go to the default case. Which means that if somehow you end up passing a list of the wrong type, of the wrong number of element, of the whatever you want, instead of having a big exception, instead of things crashing, it's just going to go to the default case, which makes your case statement far more resilient than this one. If I pass a null pointer to this one, I will just get at some point a null pointer exception. I guess, I'm not that sure, but if I pass a null pointer, or more exactly an array containing the wrong number, the wrong kind of list, I'm going to go to the default case. Again, what Scala brings us here is not really about concisions, but really about expressing clearly what I want to do. Next one. I hope I'm going too quickly about this thing. XML, I mean, who here has already, I guess everybody here has already wrote some kind of XML parser and get like fed up with this. I mean, you know, this, especially in Java when you have this complex document object create, and then you have this bizarre error, and you have to create the subtrees, document node. This is hell. And frankly, it made XML like a pain in the ass, and it's a shame because XML used to be fun. I mean, back then, like 10 years ago. Well, in Scala, XML is like a first-class citizen also, like for the function. So you can basically write XML into Scala code, and it's just going to return to you a type of data type of XML. So you can say val XML equal some XML code, and you got a variable which is typed by XML. So you can add XML stuff together, you can merge XML stuff together, you can basically handle XML like a data type, like integer, string, whatever. Also, it's quite efficient. I mean, you can write this thing directly, and you got this special syntax to pass value inside it. One could argue this is like mixing data model with programming, blah, 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 but frankly, I don't think it is. One cool thing also, if you just notice, and again, this is red, so nobody is saying anything, but encoding is here, which means that you don't really care about encoding up until the end. You just write your XML, you have XML data binding, and when you are actually going to print this out of the memory, like in the file or in the network, at this point you take care of encoding, which I found to be a good way to do it. Well, this is nice, but to be truthful, XML support in Scala has some limitation, and it can be quite tricky. You can't really order the way you want attributes. You may have an hard time doing complex things. You have no XSD validation, so you have to basically wrap some kind of Java object to do that. So it's not perfect, but it really gives you a way to quickly deal with XML. I mean, simple case, very quickly and efficiently. And also, again, going back to the expressiveness, it means that if you have an issue with this thing, when you're going to open the code, we'll have like have like a template of your XML file, not like DOM object with some add and I don't know with some set attribute thingy, which is not very clear. You're going to see directly what you are fixing. One more example, which is quite famous. This one is about ending lists, and we all know, because we are all developers, that ending list is mostly what we do. And we just create anything, any program is going to be ending lists, this sort of stuff. And this famous example was done by Martin Odersky, which is a Scala creator. So it's quite famous, and it's really, I think it really shows you how much Scala can be concise and most important, expressive. So I just create a list here of person. So I create person. Person are already defined on the first line. This is the case class. So like in the first example, with one line I can define a new object. Then I create a list of person. I don't have to type person because person is a list. A list I fill with person. So Scala is able to deduce that this list is a list of person. If I try to add something else than a person here, I'm going to have a compilation error. And then I'm going to create a new, well, actually two new lists, older and younger. Those two new lists are going to be partitioned from the person list. And I'm going to pass to the partition method a function. This is a function, the thing here. So the underscore.age superior equal 18 is a function. And the partition method is going to use this function to actually create two sublists. One will be younger, one will be older. Now just close your eyes and think about doing the same thing in Java code. Okay, scary thing. But I guess you can also think about it in other languages. I mean, it will be like very, very long, and there will be like a tons of way things can go wrong. Also, yeah.
When partition returns, does it return a list, or does it return a list when there's more than one and just one when there's one person?
Repeat question. Yeah, when partition return, does it return one list or two lists? I'm kind of shady about how this thing that actually, yeah, I just repeat the question. Yeah, I'm kind of shady about how this was going. Oh crap! Well, this was like the last example, so I'm lucky. And I was going to say, do you have any question? But that was done. Yeah, so I can just conclude, and then I can go back on the question. Conclusion is, there is a lot of noise in the Scala world about like Scala is too complex, Scala is like horrible to see. I guess it's not the point here. The point is that does Scala provide you the correct expressiveness you need to? So if you want to retain something of this whole show, just retain that. Thank you for listening, and enjoy the FOSDEM.